Okay, so hello guys. As you can see, the contest is still running this biweekly 119, and all the four have been solved. So let's discuss each and every question one by one. The first one was pretty easy, I would say, like find common elements between two arrays. So you just need to find whether how many of them is appearing in the second array, and also how many of them appearing in this first array any times. So this first number is the number of elements in the first array which are present in the second one, and this number is like how many of them that are in the second array and also present in the first array. So for that, you can see, the constraints are very low, so we can directly I have done a very simple brute force, like these are the count one and count two that we need to take. And first I iterated through the first vector and checked whether it is present in the second array or not. If it is present in the second array, I have taken a variable f, which I marked as 1 if the number is the if nums 1 of I is present in, in nums 2, so it will be equal to some nums 2 of j. So if it is found, then I mark f as 1, and if f is 1, then c is incremented, or else it is not incremented. So similarly, I checked for the second vector also, like if the number is present in the second vector, if a particular number is present in the first vector, then it is marked as f equals to 1, and then only c is incremented. At last, we need to return a vector which contains both these numbers containing. So I have returned this c1 and c2. Let's go to the second one. So it was a pretty easy question according to me. This was a bit time taking for me, and I don't know whether you were able to solve it easily or it took time for you also. So given a string, and in one operation you can pick any index I of word and change word of I to any of the other lowercase English letter. Like if you pick this A, you can change it to any letter from B till Z. Okay, and we need to return the minimum number of operations needed to remove all the adjacent almost equal characters from word from the string. So what does this almost equal character means? It means simply if the two characters are same or they're adjacent in the alphabet. Like if A is there, then A can like some number x is there. So like let's suppose x is there, then x will be almost equal to w, x and y. Okay, so like that, like here you can see, if we change this y to some, let's say a, this y to also let's say some a, and this y to also a, then this will be formed as this. And one more thing to notice here is, like z and a are not considered as this almost equal characters. Okay, so keeping this thing in mind, what my strategy was, like I have taken an initially answer equals to 0 and the length of the string given, and from I equals to 1. Why I iterated from I equals to 1? Because this was the if this character I am taking into consideration, then this I can compare with the previous one, right? And also if then there are two cases only in my solution, like if the current character is almost equal almost equal to the previous one, then it will be it then and not almost equal to the next one, just next one. Like if you consider this z y x, so here you can see this y is almost equal to this x and also almost equal to this z. So in that case, I will move my pointer to plus equals to 2. As you can see here, I have taken a previous, which is the previous word, the previous letter, that is word of I minus 1 minus a. So it will give me like an integer variable, and this is the current, that is word of I minus a. So if they are almost equal, then I will increment the answer and I plus equals to 2, right? If in the case, if absolute of previous minus current is less than equals to 1, then I will simply move to I plus equals to 2, right? So here, sorry, I am considering only this case, like if this character is almost equal to the previous one, then we will simply jump for this y, right? Skipping this x. Why? Because we are just checking the previous character in every iteration, right? The previous and the current character we are checking, and if they are almost equal, then we are jumping two indices, or else we are jumping only single index, right? And returning the answer. So it took me some time to figure this out, but at last it was an easy question. So let's jump to the third one. So this is basically a sliding window operation. So which I have taken, not sliding window but two pointers. What we are given, let's see, like we are given an array nums and an integer k. The frequency of an element x is the number of times it occurs in an array, right? So that's what frequency's definition is. And an array is called good if the frequency of each element in this array is less than equals to k, right? Whether for is subarray containing all whatever characters it is containing, if the frequency of every character is less than equals to k, then that subarray is called a good subarray. So we need to return such subarray with the longest length. Okay, so subarray, as by definition it is a contiguous non-empty subsequence, like this is a subarray, and similarly this is also a subarray, similarly this is also a subarray, this is also a subarray, like that, like a continuous part of that array. So what we need to do is to find the longest goods survey. So I have taken an unordered map of type intent, because to in just to check the frequency, like how many times a particular element has occurred in that interval. And I have taken two pointers I and j. N is the size of the array, and I have taken two variables. This answer I am returning, and this current is the, like if I find any subarray of, if I find any good subarray, then the current will keep count of its length. Okay, this is j minus I plus 1. So it works like, if I show you this, so let's say our current pointer is at here and j is at here, so j will be always leading I. Okay, so I will, in every iteration I will be incrementing my j, and since I'm incrementing my j, I also have to keep track of the frequency of that current element using that right pointer. You can say like I is the left and j is the right pointer. Okay, so if I find like the current frequency has gone beyond k, like greater than k, then it will be, then I will check like this, like if map of nums of j is greater than k and I is still less than j. What does that mean? Like we will only increment I, like the left pointer we will only increment only till it is less than or equals to our right pointer. So if it is greater than k, then we definitely need to exclude some element from our current subarray, right? Because it is not good currently. It contains some element which has greater frequency than k, right? So I will decrement the frequency and move the left pointer towards right. So what it will do, like it will remove that element from the current subarray, which is not good. Okay, and after that it will, this loop will run until uh, we got a good subarray, right? So this current will keep track of the length. So this will be the length, current equals to j minus I plus 1, and we will compare our answer with the current length and increment our j. So this loop will run till the right pointer reaches the end of the array, and at last we are returning the answer. So it was basically a two pointer approach. If you are already aware of this, then it might be easy for you, or else it will take time. Let's go to the last one. So this is basically a graph problem. So if you are aware of the shortest path algorithms, then you will then it will be easier for you to understand it. Let's go through the statement. Like, we are given n branches. So in short, what we are told to say, no, what we are told to solve, like, given n nodes, right, from 0 till n minus 1, and in between every nodes there is a path, and each path has some weight, let's say some time. Like from 0 to node 1, if you go, there are two ways. Like directly you can go 0 to 1, or you can go 0 to 2 and 2 to 1, right? So which will be the shortest, the smallest time taking path? So that will be this 0 to 1 direct, right? But like if you see here, then 0 to 1 has two paths, right? Not only two paths, actually it has three paths. So this one has a timing of 10, this one has a timing of 20, and this one, if you consider, this has timing of 4, right? So what we are told to solve, right, you can remove a subset of all these nodes, right? Yeah, like 0, 1, and 2 are given. So either you can remove 0 or 1 or 2, or 0 and 1 simultaneously, 1 and 2 simultaneously, or 2 and 0 at a time, right? Or even 0, 1, and 2 all at a time. Okay. And you need to tell, like, so how many subsets exist like that, uh, such that if you remove those nodes from this graph, all the remaining nodes from any of the other, like you can see here, the distance between the two branches is the minimum total distance traveled, and you need to you need to remove the nodes in such a way that any two nodes, after removing the remaining, among the remaining nodes, any two nodes has a shortest path less than or equals to this max distance. Okay. So looking at the constraint, this n is only up to 10, right? So it gives us like a hint of using fluid Warsaw algorithm, right? Like what fluid Warsaw algorithm is, if you guys are not aware of it, it's about like calculating the shortest path between any pair of nodes that are present in the graph, right? So how I approached it, like, since we need to check each and every subset, so I used bit masking for that, like, for calculating every subset, and I am storing it in this store, unordered set I have taken store, and inside that I am storing every subset, right? And I have also taken a distance array, 2D array, in which I am storing the distance between any of the two nodes, right? So here I have initialized, here I have marked, like, any of the two nodes, any couple of nodes will have an initial distance equals to int max, right? So this is the maximum number you can take while considering int. Okay. And after that I have gone through this vector, because this is, let's say, the graph, because in this graph, like, whichever nodes are having a path in between them is given. So I iterated through the overloads and updated our distance array. Like if b1 and b2 are the given two nodes, and their distance in between is v2, so I have updated the distance from b1 to b2 and b2 to b1 as well. Okay. And now I have taken this fluid Warsaw algorithm here. So where I have checked, like, if any of the nodes, like, calculated the distance between each and every pair of nodes once again, and then I need to do a check, right? Like if still there is some couple of node which has a distance greater than max distance, then our condition is not satisfied, because what we were told to do, like, by removing a subset of nodes, if the current remaining nodes, any couple of them, have a distance greater than max distance, then that condition should not be there. So if that condition is there, I have taken a flag variable here. So I am marking it as 0 if any such pair is found which is having a distance greater than max distance. So if that f is there, that like if that f is 1, like any such pair is not found with distance between them greater than max distance, then I am incrementing the answer, right? And at last I'm returning it. So it was basically, if you know this fluid Warsaw algorithm, then you can easily predict, like looking at the constraint how it should be, right? Yeah, so that's all. If you have any doubt, you can ask in the comment section, or else thank you for watching.